Welcome again. My name is Mike Shaleen with Codet Architectural Group, and today we are here to listen to the weather barriers, continuous insulation, and NFPA-285 from the contractor's perspective. Our two speakers today are Mike Spence, AIA, Director of Quality at Kraus Anderson Construction Company. Has over 40 years of experience in the design and construction industry, and currently is responsible for company-wide processes with a focus on integrating building science into innovative methods of delivery. And John Porter, PE, Associate AIA, is a quality manager at Kraus Anderson Construction Company, has over 20 years experience in the design and construction industry. And currently, John serves as a resource to project teams in areas of project delivery, constructability, building technology, workflow, and sequencing, as well as proper installation techniques. Please help me welcome our speakers for today. Thank you.
Good morning, everyone. As Michael said, I'm Mike Spence. Actually, as of about a month ago, my title did change. Now I'm actually VP for Building Science. As our profession is evolving, contractors too are becoming more technical in the area of building science, and why these topics are really of real passion and interest to us. As a result, John really has taken over the leadership now of Quality at KA. The other name on your program that you saw was Mike McGrath Jr., who was unfortunately called away for some meetings out of town and can't attend today. But I think the program stays the same. We'll get through the discussion. It really is more of a discussion. Don't be bashful about answering questions or asking questions, and maybe you can even help answer a few. For those of you that were in the ethics class yesterday, Peter started out by saying we might be a little uncomfortable. Hopefully this will challenge some of the conventions that we as architects have been doing and how we've been specifying and looking at some of these products. So we're fully comfortable that you may not agree with everything we're going to say, but hopefully it'll give you a chance to think about some things. As the lead and design teams, you guys do need to direct the process, and we're going to give you some thoughts on how that might work. But we're going to share our thoughts from a contractor perspective, not as, an ex-architect and an ex-structural engineer. I guess we still are those, but we've been on the contracting side for a while. So we're going to give you what's important, what does subcontractors, what do general contractors look at, worry about, and related to these topics. Like I said, it is about, from the contractor's perspective, it's about collaboration. I'm not sure if all of the comments we're going to make today work great in a hard bid environment. They work ideal in a negotiated CMR approach, and especially in the Midwest. This is really how most of our bigger projects are delivered. It is about integration, and there are some documentation things that do come up. So we're going to try to focus on a lot of this stuff throughout the process, talk about some best practices to make this happen, and how we can assure we're getting compliance from a weather barrier, from a continuous insulation, and especially from an NFPA point of view. We're going to focus a little bit on the Minnesota building code, obviously the thing that guides all our projects. As I said, identify some best practices and how we can work together to specify in detail the most appropriate exteriors. And I think our experience has been that every system can work and every system has failed. So the goal is, how do we achieve predictable performance? That's really what we're trying to get to. So it works every time. And what's the real world views, thoughts, solutions for NFPA? And a little thought on how we manage risk. When I came over to the contractor site, risk is huge because we don't have limitations of liability in our contracts. They only laughed when I brought that concept up. We're responsible for the building and probably to fix it when it does fail. We're not buffered by anything, unfortunately. But we're going to give some thoughts about how you can use some of the conventions out there to manage your risk maybe a little bit better and make sure you get the results you're looking for a little bit better. We're going to talk about why we're here, what keeps us up at night. It's usually building in cold climates. We'll certainly cover weather barriers, CI, cladding, and NFPA. I assume most of you know, if you haven't, Joe Steverick is probably one of the fathers in this industry. We're going to talk a little bit about the perfect wall, the goods and the bads, the changes. And then Jesse Vital at NFPA. What does that really mean? What was the intent? And how can we work with it today? Possibly through more aggressive delegated design, or you tell us how to do it. And we'll talk about what's performance specs, what's means and methods, which one do contractors like, which ones maybe you might want to stay away from.
Say, Mike, if I could just throw out a couple of thoughts on collaboration and risk. With regards to collaboration, we're thinking more of a mind of people not working in their silos, isolated and throwing things over the fence, but people coming together and talking, subcontractors, general contractors, design professionals, and coming together so that your solution that you've created is actually going to be implemented correctly and then is going to perform the way you expect. With regards to risk, there's a tendency sometimes to want to use your external partners as insurance policies. And, we're really trying to get away from that mindset and towards a mindset of this is exactly what we intended with our design. This is exactly what we intended of the performance and working towards that end. If you can anticipate what the performance is and if you can anticipate that everybody understands what the intent is, then things go a lot smoother.
So why are we here? Certainly with KA, we believe it's about servicing our customers. In the AE market is really, other than the client who pays the bills, you're a primary client. We need to work well together. We need to understand your concerns, risks, what keeps you up, and how we can all work together. We want to serve you and do it better. We continue to struggle with long-term performance. If we didn't, we probably wouldn't be here. How do we build it right the first time? That's sort of been the underlying theme at KA since I joined 10 years ago, to how do we do it better? Why were we having problems? What do we have to do? So that has to be first and foremost. And whatever we did yesterday, we got to do it better today. We have to continuously improve. The status quo can't stay. We have to do it better. And to do that, we need to share what's worked and what hasn't. I think the architectural side does that much better than the contractor side, now that I'm in that side. Some of that needs to rub off on the contractor side. And our customers, our clients deserve it. We have to do a better job for them. That's really what's driving us in a lot of this. Clearly, what keeps us up, we live in a cold climate. We're in zone 6 and 7. At least we're not in 8. Maybe those that freeze thaw a lot more have more problems, but just the cold. And a lot of this discussion will focus on that. Water still is a problem, although we're doing a lot better. All the focus we've had on air barriers have really solved 95% of that. Condensation is probably our next biggest one. We're going to talk a lot more about condensation today. You got to know where the dew point is. Every time you look at an exterior, roof wall or basement, Where's the dew point? That should be running through your mind all the time. And we also struggle with non-compliance. We want to follow your documents. We need to follow your documents. It's our contractual obligation to follow them. But we see conflicts between specifications and manufacturer's requirements. We see undefined performance requirements. And we need to have interfaces better defined.
So Mike, between water intrusion and condensation, what would you say that that builds in terms of percentage of callbacks for us?
I think one of the things that was interesting, I was at a focus group with one of the major manufacturers, and they had a series of consultants, a couple from Canada. Water intrusion is still sort of the lead, but the conversation of winter rain keeps coming up. When we see liquid water this time of year and through March, that's not water intrusion, that's condensation. And I think certainly in this area, we're doing a good job of sealing up the outside, but we're doing a crappy job of understanding condensation. And continuous insulation, understanding weather barriers, understanding cladding and attachment systems will get us there. We have a solution, I think.
In terms of long-term performance, I just want to throw this out. You know, we don't always know by reading the documents if the intent is for a 50-year building or a 3-year building. And this is something I see as a great opportunity for the industry to work through. What does the owner want? Well, the owner's, you know, maybe the owner's budget and their desires aren't aligned, but how do we communicate this from beginning of project through completion of, are we trying to build a system, an exterior wall, a building enclosure that's going to last X years or it's going to last Y years? And that's something that's a real huge gap.
Yeah. Picture, you're right, that's a year and a half old. That happens to be OSB and an exterior wall behind a lick and stick stone. They're big sponges. Durability is not sort of compatible. Water intrusion, yeah, we get the black biologicals. They can't say we can use mold anymore. How do we keep it dry?
Actually, our insurance company calls it the M word.
Yeah. School districts cringe, and they should. This happens. This is a little older in a few years. This is mostly about air infiltration causing black biologicals. Understand where the dew points are and what's happening. Keep the inside surfaces warm. This was not a bad window system. It was put over the top of the airspace. It was outside the building. It was in a hospital. We replaced 106 windows last year. A building that was 9 years old. The architect, we followed the documents, by the way. The window was put outside. It got cold. They had a program for managing the white towels on all the windows. Thermal bridging, whether it's studs without continuous CI or Z-furring going through that layer, we get pictures that look like this. When you get this differential, you also get condensation. We struggle with workmanship. It's not just a design problem, trust me. We got to build it right. These are just a couple of simple little pictures. You know, the specs clearly say continuous vapor barrier, continuous weather barrier. We stick things through it and we don't remember to go back. We work hard to try to prevent this, but it does happen. And yes, that's duct tape. It works for everything. I thought at first it was going to be a temporary patch. The installing subcontractor didn't think so until they tore it all off. But workmanship has to be a concern. as an architect, you need to talk to your contractors and make sure they're aware. Don't tell them what to do, but make sure they're aware. The before and after, we had some junction boxes on the outside, so you just sort of wrap the pipe with the weather barrier. You don't really need flash. Well, we did slow them back or slow them down, and we did come back and fix it.
If I could just throw out here, one of the last things to be figured out on any project is the signage, and this is an issue. We're always sitting in a room looking at each other saying, okay, we need to poke through this system. How are we going to do this without tearing the entire wall down back to its weather-resistive barrier and rebuilding it again?
I would encourage you to push your owners. They're going to look negatively at you. If we put the cladding over the facade, after we put the weather barrier, the insulation, the cladding attachment system, got it all nice and pretty, now you have to come in and drill some holes because the signage to be determined was never quite determined. And we're going to tell you, we got to tear it all off. Or, Mr. Owner, Mr. Architect, you're responsible. These are big cost items, so push your owners to get this stuff defined. If you don't, we'll be the bad guy. We have to be, but we'd rather have you guys be the good guy. We got to clean substrates. The one on the left, all these hats and stuff that go over these weather barrier systems today, if you read the manufacturer's requirements, they all want something behind the screws or behind these hats. Either an extra layer or a layer of peel and stick, something to help seal the nail hole or this fastener hole. So what's different today? We have new building codes as of a couple of years ago and a lot more awareness. I think we have 3 programs this year alone on weather barriers at the convention, so go to the next couple as well. We've had them for the last several years. The code guys are getting together and they're talking. And the 2 codes that are out there are quite similar, but a little different. And the consulting market is getting more and more aggressive, unfortunately. We understand building science better today. Like I said, we're one of the contractors who have an internal group now focused on building science. We're not alone, especially on the East and West Coasts. There are a lot of specialty consultants out there. The bar is being raised. As Joe Steverick talks about, sort of the 5 control layers, water, air, thermal, vapor, and then the cladding is sort of what we keep it all covered, but it does keep the UV off. And it should be providing a back ventilated system. Probably not pressure equalized, but probably at least back ventilated. The key word is going to be continuous. As we all know, these are assemblies. It's not just the little components, but it's about air, water, vapor, and thermal. All needs to be viewed as an overall assembly. They work together. We've all heard many times you change one piece, we change it all. We're looking for better understanding about performance. What do you expect it to do mathematically from a science point of view, and how long do you expect it to last?
Yeah, I'd just like to throw out with regards to performance, we as architects and contractors need to be able to tell owners, building owners and building end users, this is what we were trying to accomplish. Whether it was no condensation at a 30% humidity and an exterior temperature of -15 or an interior humidity of 70%, we need to be able to go back to them after the fact when they call us and they say, I have fogging windows, and, be able to trace a line back to why we got to our end point.
You know, we see a lot of specifications that talk about on a rain screen metal panel system, water resistance of 15 pounds. All the joints are open. The panels are designed to leak. It's the weather barrier behind it that's keeping the water out. It's not the metal panels. They're screening it, yes. But by definition, 1, 2, 3% is supposed to get through to the back. And then when you really look at what it takes to pressure equalize walls, maybe you even need more air than that. Start to understand, it's pretty easy to get a 20-year building. It's really hard to get a 75-year building. Sealants, in my opinion, probably go away. You're relying on true pressure equalization. Those are custom walls. But think about these criteria, and from an architectural point of view, how do you convey that to us? How do you share that and get concurrence with the owner? Because that's who we're building the building for. What do they want? What do they need? So let's dive a little deeper into the first piece of this, the weather barriers. Under 1403, it defines it nicely under the Minnesota Code. It says that all the walls shall have one, that it will include flashing, something to remove the water from the inside. They're acknowledging that it's not watertight. To prevent the accumulation of water and to provide that barrier behind the veneer. And protect against condensation. I'm sure we've all read it a number of times. If you haven't, read it a lot more. And figure out, what does it mean to you? There are some exceptions.
Some bad idea exceptions.
Yeah. And obviously, as we talk a little bit about NFPA, Minnesota has excluded the vertical and lateral flame propagation in the code. I'm not exactly sure what that means, because all the consultants counted in their caloric count for flammability. Whether we need to or don't, it's that way.
This is kind of an odd deletion because you can't get an engineering judgment letter that ignores the weather barrier. So it's kind of like, why did they delete it? And unless the intent is to actually run the fire test and run the fire test with assemblies that don't have a weather barrier in them. So it's just kind of a strange thing.
Yep.
The reason it was deleted is because when the code was adopted, there was like one tested assembly available in the country.
Yes. So many of that comes into play, and I was actually at a BEC conference with the main one mechanically attached weather barrier people out of Chicago, and her comment was, the problem is going to be that they're going to test all of these assemblies for zones 1 through 5. Problem is, we live in a zone 6 and 7. There's no people that live here, so manufacturers are going to put their money where the people are. It's simple mathematics. So where it's cold, we don't get that. So that was a big part of it.
Another interesting thing to that, the percentage of assemblies approved on the basis of engineering judgment versus on the basis of test. The engineering judgment has way blown by the tested assemblies at this point.
I think the other thing that I found interesting going back through, we all talk about this 40-foot thing. This was in the paragraph that we deleted, by the way. I think the all buildings covered, we'll get to that. So just one of the other many things. We also require a weather barrier, and this is still old. This is the current language. Talks about 15-pound asphalt felts or other approved materials. Focus on the other approved materials. Don't put paper in your outside wall. You saw what happened with the OSB. That's just a better version of paper.
Structural paper.
It's structural paper. And it's not an air barrier. Don't think that layered felts are an air barrier. We need vapor barriers. As soon as we add one, make real sure you know where the dew point occurs. Because especially if you think that we can put a piece of 6 mil poly on the inside of studs and then screw one fastener every 1 square foot through the face of it and think it's actually going to keep out vapor pressure. We have things like outlets and things. We can work with some of those things. Floor slabs are hard. Intersecting walls are hard. You saw the earlier picture. That was an intersecting wall and not well sealed. We have some techniques to do it better, but those are timely and expensive.
This is a little interesting thing in the code where they specifically call out vapor retarders on the interior side. And this kind of presents a little confusion amongst us. When you have a combined air and vapor barrier that's on the outside, are you violating the code?
It's outside of the framing, isn't it?
Yeah, so that's an interesting
But it's
one
on the
too.
inside of the weather barrier or on the insulation layer. I think we're all interpreting that's okay. Under IECC in the code, we do have some definitions of air barriers. I think the key words here are continuous. You got to seal all the holes, penetrations, and joints. And it has to take positive and negative load. So a sprayed membrane over a 2-inch expansion joint without backing, does it work? I don't know. You tell us it does, we can rely on that. But maybe we need to talk a little deeper. ASHRAE uses almost the same definitions. We need it over the entire building. That includes the floor, I think. It needs to be clearly indicated or otherwise noted on the construction documents. One of the things that John and I do and all of the building consultant type people in here when they do constructability reviews. Yes, you put your pencil down here and you try to start tracing it and you don't pick it up. And when we have to pick it up because the line is not continuous, we send an RFI in or a question. You have to show us, give us a path to get there. And walk through in your mind, is it continuous? At the window, at the interface, at the floor slab, especially on the vapor barrier. How do you run it up the inside, get through the concrete slab? Is that impervious? No. What really happens there? Challenge it. Don't just say we've always done it this way. Did I skip one? No. Our focus on air barriers have really helped. We've gotten better buildings. Our mechanical loads have gone down. It's a better interior environment. And it's helped prevent many of the condensation issues. But we still struggle with ill-timed holes, bad laps, sprays over bad substrates. They almost have to be smooth. Three-dimensionality. We have ins and outs and corners and all this stuff. How do we detail them? The product you specified, does it work well here? How flexible is it?
Yeah, this is actually this is a case where we were not only transitioning between one product and another product and then turning corners horizontally and vertically, but then diving down beneath windows. So it was, and you know, we have a typical section cut through the sill and we have a typical section cut through the, you know, opaque wall, and that's it. And so it gets really challenging really quick.
So let's talk a little bit about the thermal layer, CI. it's a different approach for detailing exterior walls. It's a new thought. It's a change. None of us deal well with change, even though we talk about it. It's really about an effective U value or an effective R value across the entire surface. You know, in the passive home market, they talk a lot about psi values. That little bitty screw going through is really bad at that little point. We're not even close to that yet. But the codes do talk pretty well about what does it mean. Under a performance path, it allows some customization, but start thinking about it not so much in the R value table, but go to the U value table and start looking at that .064. And what does that really mean coming back to us? And if we really get into performance modeling, I think you need to specify how we get there, or specify the criteria that we need to get to. And why is this important for contractors? We like continuous insulation. It was really a savior here. Why? It's going to prevent condensation if it is continuous. The two codes actually say the same words. That's unique. But it says continuous across all structural members without thermal bridging other than fasteners. So what's a fastener? As the design professional, the architectural record, you get to define that. It's a code interpretation. I've seen it being a screw. I've seen being a 6-inch piece of Z-furring cut off. I've seen it being a 24-inch piece of Z-furring cut off. You got to define it. We all know how ineffective stud walls are. John and I were having a debate internally about 16 gauge, 18 gauge, 24 gauge studs. Okay, this table is at 16. They have another table for 24. What happens at these mega jam studs we have? What happens at corners? What happens at interfaces? In the wood frame market, there's a lot of discussion about optimum wood framing and how do we minimize studs in a wall. We're not there in steel studs yet. We need to be thinking about the impact of the steel studs.
I would say even in the wood frame market, I mean, when we get king studs or jams that have 6 2-bys, you know, there is no insulation other than the wood. The wood is the insulation.
Yeah. We do a lot of 5-story wood frame apartment buildings. The bottom floors are almost mostly wood. We get 1.2, 1.25 per inch of wood. It's better than steel studs, but that's it. So we're not contributing a lot. This little table, which you probably can't read, but it does say that the codes are going to get worse next time around. The CI, as we know, went from 3.5 to 7.5, and now it looks like it's going to be 12.5. They kept the R value the same because it's almost worthless. It equates to about 1.5 inches of insulation. Put it all outside. Don't put it twice. If you put it inside, now you got the interior vapor barrier to deal with. Can you really attest that it's airtight, vapor tight?
Or can you tell us where the dew point is?
Yeah. And I know I'm confused on WFI models. If you're really proficient on them and do for every wall type you have in your building, we'll believe you. But you should. But I go back to Joe Steverick's perfect wall. It's dated a little bit. It's 2007, because that's 10 years ago. And it's a pretty simple process. He's matured this since then. He has a couple of 3 or 4 different versions, some with block. He does show a split wall for residential or light commercial applications with some caveats. If you haven't read a lot of Joe's stuff, do it. Just search on Building Construction Corp. They have a great website. It's really he's driven a lot. He spoke here a couple of years ago. He's classic Canadian. I don't know if we'll have him back, but he's always great to listen to. He takes a pretty simple approach. You know, if you can't keep the rain out, don't worry about the rain. I mean, don't worry about the air. We've done a pretty good job of keeping most of the rain out. We've been focusing a lot on the air. Now it's some of these harder things like vapor and thermal. But what he really says in a perfect wall, and I truly believe, and I encourage all of you to think about it, put all the control layers, certainly the water stuff, the vapor stuff, the weather stuff, the thermal stuff, outside of the structure. Keep it warm. Don't let it go through 110 degrees thermal cycle. If you do, make sure you got big enough expansion control joints to accommodate it, because the building will move. Simple concept, put it all on the outside. Don't think that it's cheaper to put bats in stud walls. It is, but will it work? Challenges with CI is not making the insulation continuous. It's how do we hold the cladding on the outside. Maybe EFIS does a pretty good job of this. We've had a lot of issues with EFIS, but it can be done well and it can be done right. It's not inexpensive anymore. But we used to hold stuff out with a simple Z-furring. I challenge you to make sure it does comply.
I just like to point out here, you know, with cladding attachment systems, the cladding industry, with the exception of precasters, is kind of going through an anxiety and a growing pain that precasters did 20 or 30 years ago, and it's basically a question of how do we hold all this weight way out here without it falling off the building. And so, you know, there's a lot of churning in the cladding attachment specialty engineering industry, because they're trying to grapple with this and figure out how to get these things to not just be 1 inch off of the slab edge, but in some cases be 8 or 9 inches off the slab edge.
One of those structural things, and we got to call somebody who knows more than we do. There's a lot of discussion as well about mineral fiber and polyisos. I mean, extrudeds, moldeds have sort of gone away for a while till they can figure out how to make them non-combustible, or at least type A. But mineral fiber is great. Doesn't burn. Doesn't insulate as well. And you certainly can't attach much to it. Polyisos, on the other hand, you can compress things and it's rigid and you got great R value, but they burn. So what's that balance? Don't believe everything you hear from your peddlers. Sorry for those peddlers in the room. Manufacturers' reps. And we all rely upon them, but talk to more than just one. It's really coming down to that cladding attachment. It's a new cost to understand. We're going to talk a little bit about pricing coming up. But what's the criteria for the cladding attachment? Is John's, you know, we got this moment arm sticking out. How heavy is the cladding? What's the wind on it? It's a dynamic wind, so it's fluctuating, and that's transferring loads back. Who designs it? Who selects it? We'll come back to that one. So if we put all the insulation on the outside, how do we support the cladding? It wasn't that hard when it was 1 inch. And then it was 1.5 inches, now it's 2, and now it's really 3 inches or 4 inches of mineral fiber. How do we get out past that? Z-furring was the simple solution. We now have a better definition of continuous. What's that fastener look like? What's it made out of? How thick is it? What's the spacing? What's the bite? You know, we used to have problems in brick ties a long time ago when I was young, and we went through that whole discussion about even the pattern of the screws. Thermal transfer has certainly saved energy and it's prevented a lot of condensation. But what's happening with these fasteners over time? Will they work? They must be engineered for the project. I don't think your structural engineer of record is going to do that for you. I don't think you guys should. Fortunately, probably says put it in delegated design and push it back to us, and we conveniently will push it back to our subcontractor, who will in turn push it back to their delegated design engineer. Hopefully that entity understands exterior walls and not just has the PE that he wants to sign things. We have big things that go through walls. We hang a lot of stuff outside. Those are great paths to condensation. There are ways of insulating that now, or even covering it up with thermal coatings.
Yeah, we've seen the, I think it's an aerogel-based acrylic paint. We've seen neoprene pads that interrupt outriggers that are coming through. Or we've seen, like, the photo you see here on the left. That's kind of the, I don't know, sketchy way of doing it. But people are thinking more and more about this, and we're seeing a little bit more sophistication in the solutions.
We'll usually run, many times we'll run thermal models of these. Don't allow us to get to that point, because we're only doing the thermal models to show you that it doesn't work. Think about it yourself. Don't wait for us to ask. It's expensive and too late. If you're working with a contractor ahead of time, talk. Yeah, we have probably easier ways of funding some of this stuff. Balconies. We do a lot of high-rise housing. Balconies are going to become an issue, but there are solutions. The new energy code is driving in the right direction. We have to, don't give up. Hold your ground. Tell us we got to provide these insulated strips between them. They're not cheap, but they're not that expensive, and they work. Takes a little coordination. That's a change for us. We got to rethink. We all struggle with change, don't we? Cladding attachment. You really need to answer this question. I've heard more than one architect say that we still use it. It works. It complies. Why wouldn't it? We're seeing cross Zs. Some are bigger projects, take Zs and go, vertically and horizontally. I think that can comply. You got a little nominally 2-inch square spot in the middle that may be a problem. Understand that, model it.
That's presuming you have 2 layers of insulation through each
Yes.
plane of Z.
There's a hat channel with engineered fasteners, one that we've been using for a while. Now we're finding some of the delegated design engineers are questioning it. And it gets into the gauge of the hats, the size of the fasteners, the profile of the tooth of the fastener, the spacing, the coating, but they can still work.
So this is a point where it would be really great if the XPS industry could figure out how to prevent their product from burning, because XPS has a higher compressive strength. Its blowing agent is friendlier than polyisos, and its R value doesn't take a nosedive in cold weather.
Just a few challenges. Now, there's a lot of proprietary systems out in the market. I'm sure there's a lot out on the floor. Go talk to them, but talk to all of them. And we're going to show some diagrams and issues, goods and bads. There's proprietary rail systems with fasteners. Many of those fasteners are stainless steel and heavily engineered. There are some non-proprietary rail and clip systems. Some are thermal, some are not. Keep in mind, not all climates require thermal. You go south, they don't. There's much. There's thermal clips with rails. There's proprietary thermal clips. And there's certainly we're seeing more and more thermal struts, thermal Zs, all coming on the market. High-tech plastics, carbons, composites. let's take a little sidebar and talk about the elephant in the room. It's this cladding attachment. Fasteners are, as you've heard, and from a contractor, subcontractor point of view, fasteners are a big deal today. And how they react long-term, 30, 40, 50 years to wind fluctuations on buildings. Buildings move, substrates move. How do they react to that? We don't really have proven history yet. We need to start thinking about it, and will they loosen over time? And are they a source for future air and water? I think so. We need solid delegated design, and you're going to be hearing from us. We support that. Not all contractors, not all project managers within our organization like this idea, but I think we need, as an industry, move this way more. It's going to put some additional requirements on the constructor side, and you guys have to help by specifying the criteria and the means of evaluating that criteria. We'll touch on that a little bit. But things like wind, the design of the fasteners, thermal, how does it comply? Cladding attachment is specific to the cladding system. Mostly the weight and the pattern layout configuration, how combustible it is, and the size of the airspace. This came back to bite us on a recent project not too long ago as the space changes. We're going to walk through some pictures here. We got vertical Z's, pretty straightforward, it was really easy. Horizontal Z's, you got a little less contact. Very traditional way of doing it. I don't believe either of these comply with the current code.
With the definition of continuous insulation.
Yes. Now, if you fill a cavity full of insulation, maybe. If you do a performance model, you can get these to pass. We're going to raise our hand and say, yeah, but will you relieve us of the liability of the condensation at all those spots? Thank you, because you just probably did. And what does that mean? Cross Cs, I think they're pretty effective. Very, very expensive. You're putting 2 layers on. This is sort of the rail system with the engineered fastener. As you can see, it's the fastener is the only thing holding it in place. Very little thermal bridging, really good thermal performance. But we got to engineer all the pieces. We've used it on a number of our projects, we think successfully. Time will tell. But we're seeing not 16 or 18 gauge hats, we're seeing 12 gauge hats with much closer spacing of fasteners. The 16 gauge at 24 worked until they involved their engineer. Then all of a sudden they became closer and heavier and bigger feet on them to transfer the load into the insulation. We also found that the compression strength is somewhere, give or take the size of the hats, 18, 19 PSI to 23, 24 PSI. ISOs come in 16, 20, and 25. Of course, 25 costs more. Do you just want to arbitrarily spec it? Or you want to put that into the mix of what we all have to think about. Make the hats bigger, the insulation can be cheaper. There are some proprietary 2-directional systems, again with long fasteners. Anytime you're using mineral fiber, you got to use some type of a clip system to get back to the primary structure. You can see these are a lot more sophisticated than a simple Z. And that sophistication usually costs money. We'll talk a little bit about that. The uninsulated rail and clip, proprietary systems with thermal clips, maybe with just a spacer, but trying to thin up the thing. Insulation at the top and bottom. How far does the rail penetrate into the continuous layer? You know, we only need that R7.5 right now. Maybe it's going to go to 12.5, so that says you can poke into it a ways. Do you want to? Do you need to? Some of the composite systems, these look pretty good. We've used some. We're starting to see more and more of them. They are not inexpensive. There are a lot of little pieces, but they carry pretty good loads. You have really proprietary clips. So let's talk a little bit about the money side. We're contractors, we talk about money. We started with a very elaborate little matrix with real dollars in there, and we took that out. Well, access, volume, size, weather, geographic location, all impact. But we're going to give you some ratios. You know, a few years ago, Z-Furring was relatively cheap. Buck and a half, $2.50 a square foot. These new systems, depending upon the weight of the panels and the type of insulation, $4 to $15 a square foot. These are not small numbers anymore. Contractors, subcontractors, general contractors, we're not all catching it at the right time. Go back to your specs and look. How many, in your panel sections, have you specified a cladding attachment system? You might have inferred it, but have you spec'd it? Knowing that this is half the cost of the panel. You've got a $35 panel. You got $15 to hold it on the wall. Did you include that? So what does that really mean? You know, in our area, we're shooting for that U value, 0.064, sort of that 17 plus R value. So 3 inches of ISO gets us 17, 18, 19, depending upon who's, sort of 4 inches of mineral fiber, we're close. We're in the high 16s, low 17s maybe. You got the Z-Furring being cheap. I don't know if it complies with code. Cross these, because you got 2 layers of them, go up quite high. Hat channels with engineering fasteners, in my mind, is sort of the new baseline. The proprietary stuff goes up, and the really high-tech systems, the ones that will hold all of the stuff, that covers all the high-end thermal stuff, the manufacturers that can give you all of the technical data to make you feel happy, are definitely at the high end. Mineral fiber is a pain to work with. If you've played with it, cut it, especially in the summer when it's warm and hot, you want to be in your little, white bunny suit doing all of this stuff. It costs more to install for the same R value. It does, but it doesn't burn. If you're going to use some of the HPLs, you pretty much have to use the mineral fiber today because the ISOs still contribute too much flame content. So you got a more expensive cladding, it's heavier, and a more expensive cladding attachment. And terracotta is expensive only because of the weight that we're dealing with. Metal panels are in that, 2-pound range, something like that. 7 pounds sort of work. You get beyond that and the prices just go up. Question? Yes.
So if you believe that polyiso nosedives its R values when it gets cold, is 3 inches really enough, or does ISO need to be 4 or 5 inches? An R of 3.
Can you repeat that?
Yes, I will. With the thermal loss due to cold weather of polyisos, how much do you really need? Right now, my calculation of the math, to meet the 0.064, we need about 15.65, there's 15.6 R value of the insulation. Most of the polyisos that we buy with facers are probably in that 18 range. The outside inch, that first inch that's exposed to the cold, yeah, I think there's some loss. The next inch end is warmer. What is the actual temperature of that inch as you go in? And then the last inch, where are you at? If you're really going to be anal, you might want to look at that.
I think from my perspective, I think there's a disconnect between the material suppliers industries and the design industry. I don't know if you guys remember back when back in the roofing industry when they had to reset all the LTTRs for roof board insulation. Well, each industry, polyiso, XPS, they have their own methods of calculating R value. Well, R value is dependent on your temperature. You know, you're basically doing a U value, a heat box test with an outside and inside temperature. And each industry is choosing their own set points for those temperatures. So it's, you know, not to be cynical, but it's somewhat of a mess. And it'd be great if there could be a uniform alignment of what R value really means, because it changes.
Keep in mind the code is the minimum. That does not prevent you from doing a better job for your owner. I was involved in a project back in turn of the century, I guess. Late 90s. The owner thought, and we put in 4 inches of mineral fiber back in 1998. We increased the R value. You don't have to do the minimums. Was it last year that Steve Dockett was here and we got to listen to his PhD thesis? I've listened to it 3 times and I almost understand part of it. The whole issue about wind washing and mineral fiber. Okay, yeah. Polyisos degrade, I accept that. Mineral fibers that top 1, 2, 3 inches that the air blows through, certainly the top 1 or 2 inches. What's really your value there, assuming you keep it dry? The mineral fiber ice insulates well. The water that might be in it momentarily, how well does that insulate? It's a real challenge out there.
I think the bigger issue, getting back to your question, is, you know, what is the entire envelope's U value? We're trying to minimize. We're trying to slow down how fast heat crosses that plane, and you know, the code, the prescriptive paths for energy code compliance. I mean, they provide an easy, I'm going to say, quasi-easy way of getting there, but they don't directly attack the bigger question of, hey, we're trying to minimize or slow down as much as possible this heat going across this plane. So we're just living in this R value world, and hopefully we can get away from it and get into assembly U values eventually.
Some, you know, more innovative creative manufacturers are looking at vacuum packed bags and stuff like that that will give us 50 in an inch. They can't market it yet, they can't price it yet, but they're researching it. If we can get get XPS non-combustible, that's going to help a whole bunch, won't it? Or we build a lot of 24-inch wide earth shelf or compacted earth foundations. It's sort of cool. But moving on a little bit, the other thing we struggle with a lot, everybody has been confused. I'm not going to give you a solution here, by the way. We're going to maybe give you a path to explore, and together maybe we can get something that works to all of our satisfactions. Why is NFPA a big deal? Well, we saw it in London not too long ago. We've seen it around the world. Knowing that it was really created for dense urban areas and trying to prevent flashovers in non-sprinkled buildings. We don't do many multi-story buildings that aren't sprinkled, but it's a requirement. 2603.5, you know, exterior walls of buildings of any height, doesn't say 40 feet, does it? Any height. Exterior walls of buildings of type 1, 2, 3, and 4, so that area most of us all play in, shall comply with these requirements. Wood frame is separate, but other than wood frame, this is the marching orders. NFPA complies, unless, like shows at the bottom, 1-story buildings are excluded. Right? Fire has no place to jump up. It does say we got to use the Class A insulation, Some of the manufacturers are testing type 2s, by the way, or class 2s. I don't know if that allows you to use it or not. This is pretty specific, I think. Talks a little bit about ignition and what you can put over the top to exclude some of it. But here's the test. And it's how far up does the wall, does the flame go from the window, and will it jump in up above or cause catastrophic issues? You can see the past one and you can see the failed one. So we're trying to limit that burning going up the wall. Or jumping from floor to floor and coming back in the window up above. My knowledge, listening to some of the smarter people on this, there doesn't seem to be a documented case of a fully sprinkled building where this has ever happened. That's not to say that it can't. And until the code gets changed, maybe next time around, maybe we can deal with some of this stuff differently. Oops. So what does this mean? We can detail and specify only tested assemblies. There are quite a few of them out there today. All the major weather barrier people are probably doing one or several. All the insulation people are probably doing one, and a couple of the cladding people that might burn are doing one. But it needs to be an assembly with all the specific components. The weather barrier, maybe not in Minnesota, but the rest of the world. Insulation, the size of the air chamber, and you're going to see that's coming down to maybe 2 1/4 to 2 3/8 inches. Air chamber, detailing around the openings. We've had a lot of discussions with many of you in the room about how do we detail around windows. What does the test show for that particular assembly? You don't have to do all the special stuff. Sometimes a certain gauge of metal works. Sometimes a couple pieces of wood blocking works. Yeah, sometimes we got to use a bunch of mineral fibers stuck in there as a baffle. It depends upon the assembly. One detail doesn't fit them all. And it's dependent upon the cladding. So you can specify that, and we can provide it. We'll follow your direction. You're telling us what to do and how to do it. We like that. Or you can come up with your own custom requirements. Many projects do. And we can have them test it. It's not unusual. They're $40,000, $50,000, $60,000. The problem is getting them scheduled. They're several months. And you really got to have the horsepower of an insulation guy or a weather barrier guy to really get it in line at UL or one of the other testing labs. And if it fails, you got to keep retesting. That's $40,000 each time. Or we can use engineering judgment letters. We have a lot of history today, and especially fire consultants, Hughes, Priest, and there's more and more growing, have great reputation and great credibility with the local jurisdictions. They trust them. They believe them. Even the city of Minneapolis, when we had Jesse Vital on the phone, he said yes, or the city said yes. We can do it this way based on their expertise. It happened to be for the first high-rise wood frame building done here, the T3 project that we did. As been referred to the Mother May I letters. I love that. Can I do this if I say all these things? Honestly, from my evaluations, I think it's a pretty rational approach. They're conservative, they're done by smart people, and they need to be smart, they gotta have credentials. But it takes cooperation, not just with you guys, but more importantly with the authorities having jurisdiction.
So I just like to throw out a question here, because this is a little side project of mine that I'm not getting anywhere on. Rated UL assemblies, in the history of UL, did they actually test every single assembly? Is that Is that true? Okay. So this is a totally different scene. NFPA-285, they're not testing every assembly. They're basically creating letters saying, yeah, close enough.
Yeah.
And
Now-
so, Mike's perspective is it's rational. My perspective is, I don't know. I mean,
Difference between the architect and the engineer.
they're taking something and they're extrapolating it. I mean, isn't that what they did with mortgage-backed securities and collateralized debt obligations? I mean, so it's a little bit, I don't know.
It might bring us back to one of the top two. Or we're going to be able to hang on long enough to get past to the next code generation. And we got to be vocal on what's practical, reasonable, and where we are having risks and what other things do to prevent it. Yeah, Nancy?
Can you expand more on the who writes it thing? Are they cladding people? Who are you seeing writing this?
Who writes these engineering judgments? And it needs to be by a credible source. These are typically licensed specialty fire protection groups. The two I know of right now is Hughes Associates and Priest Associates. As we look at picking subcontractors for cladding, we're asking them, who are you going to use for delegated design for these? Who's doing your NFPA compliance backup data? We need to make sure it goes through. We want to have a real person talking. If they bring in somebody new, the questions get raised. Have they done it before? What's their experience? Do they really have the expertise? Can they stand up and convince the city of Minneapolis, which is probably one of the harder groups, that they have all their ducks lined up? And it gets into understanding the caloric count for each of the components in the assembly and how much heat it generates and therefore how much it will. And as long as they can take a base model and show that what we're proposing is less by some tolerance that's reasonable, and these things have been pretty straightforward. But that's at a pretty high level that's beyond probably most of us in the room.
And in our experience, these letters are, I don't know, I want to say 6,000-ish, and about a week and a half, 2 weeks, depending on if they're in Tahiti or not, and so.
It doesn't come free anymore. I mentioned the airspace. We had a project, architect wanted a little articulation on the wall, sounded great. We pushed it out. And the subcontractor caught this themselves. They said, dang it, we had a 4-inch airspace. What do we do? Why? Because the airflow goes up a lot faster, we've got a lot more air moving, therefore the flame spread is going to be a lot quicker. And they talked, in this case, to Priest Associates. They came back and said, you're right, it's going to fail. We won't sign off on it. Well, we were able to fill that gap of the extra 2 inches of airspace to meet the profile requirements with filling full of mineral fiber. Non-combustible, it was a filler. We ran it by the authority having jurisdiction, and they said, sounds good to me. That's the dialogue we have to start to have. I think we got lucky there, to be honest, other than moving the wall back and forth. Another project, we actually moved the whole outside wall out. We jogged the studs, a little bit more expensive. I mentioned about detailing around openings. It really varies. A lot of the tests are run with the least common denominator. A lot of times that's a piece of 16 gauge metal at the head of the windows. Sometimes it works, sometimes it doesn't. These manufacturers who have done these tests and the fire consultants know when it does and doesn't. If your office standard is to show 8 inches of 3-inch mineral fiber around all the openings, we'll build it that way, but it comes at a price. It's a very safe price, maybe $300 an opening, and you've put in a $300 window into that to save money, then we bring it up in value management. Is that the best way to go? No. So talk to your contractors. We need to talk to our subs. We need to talk to the manufacturers and how we can get by doing the best system for the application at that time for that project. I'm going to strongly suggest in the next few minutes that you really think about figuring out what that criteria is for that exterior wall. You're specifying tons of delegated design now. Enhance the ones on the outside cladding and include it into there. It does make the contractor responsible for it all. We have to have the criteria designed to, under the building code, we're not responsible to do professional services unless you tell us to do it. And you must specify the criteria which we're to play under. And it's not just globally same per Minnesota Building Code. You got to be more specific. And you need to define for us what the submittal requirements are to confirm compliance. A true performance spec. Some of us like it in the contracting side. Even in KA, there are some that don't, because we got to think more. It takes more time, but it gives us flexibility. But things that contribute to this, we know solid metal panels, profiles, solid plates, don't burn. We're pretty safe there. ACM panels, I don't see where PE cores work anymore. Why spec them? Now, PE cores are cheaper than the fire core material. Not on the product itself, but as soon as you start to cut it or bend it, they eat up saws like crazy. Terracotta and cement fiber, or fiber cement, don't burn. They're really good, but they're heavy. They have other issues now, especially the cement fiber on silica dust issues. The cladding attachment system becomes critical. Phenolic panels and high pressure laminates are really cool. So I think we've talked about why. What do we typically see? How are we doing? Yeah, okay. Most of the specs talk about here's a list of bases of design, here's a list of the manufacturers. Use this air barrier, put the vapor barrier here. Here's the type of weather barrier to use. You got to use 12.5 perm ratings, not 12.8. They're very specific. How it's applied, how it's attached. Is it mechanically attached? Is it fluid? No, you can only use this particular one. And what thicknesses to apply it at. Very prescriptive. We like it. You're telling us what to do. Use this insulation at these thicknesses. Attach the cladding this way. Do the openings. And then you do ask us, tell us that it complies. You're telling us what to do. You're very prescriptive. You're getting into means and methods. Truly, you've picked how we achieve the results. I've read through a lot. This is just the graphic more so than words. This is 3 little vignettes of all of the tables that the various manufacturers publish for what their products have been tested in conjunction with. Or part of some of the compliance letters we'll see. All we have to do is build it. And if it fails, we have the right of reliance, by the way. You guys are front and center to defend it and to tell us why you picked that system and why it should have worked. What I'm going to suggest we do instead, because I think that the specialty contracting market might, in conjunction with their manufacturers, might be in a better position to answer some of the questions. I don't expect you all to agree with this one, but I think that you need to specify the criteria, but don't specify how we achieve it. Get out of the means and methods discussion. Focus on the end results. As a contractor, we like it when you tell us how to do it. There's great historical legal documents that allow us to follow those documents. It's higher risk for you. It's not easy to specify just the end results without telling you how to do it, but I believe it can be done. If you do a true performance spec, you have to have a way of confirming compliance. It can be documentation. We don't have to do a full test. But it may take coordination with the authority to make sure they're comfortable with it. How to specify it? We're going to, yeah. The air barriers, yes, we need one. Maybe you should be specifying not what the product does, but what the building does. We're seeing blower door testing more and more today. It will come in the future codes. It's a good thing to do. And you can even spec more stringent criteria than the 0.4. The buildings we're testing are below 0.1 with a meaningful attention to sealing them, but we can get there. Everybody can get there with some attention and good detailing. Weather barriers. Okay, permeable or non-permeable, that might be enough. Does it have to be? What's the perm rating we really need? What type of water resistance does the weather barrier need or the wall needs to resist? You heard my comments on the cladding. What's holding the water up? This is the weather barrier. Maybe that should be the design pressure for the water testing. Pick something. Do something reasonable there. Why do you care if it's mechanically attached fluid applied to a sheet? Other than you've listened to a bunch of the manufacturers who want to sell them. Dump that back to us. If it's in the summer, we might pick one. If it's in the winter, we're probably going to pick something else. If it's 8 stories in a building in downtown Minneapolis, we're not going to use a spray product unless we can close all the scaffolding. If we prefab it, the rules change. R values, don't think about just R values, start thinking of overall U values. Just as the curtain wall market has gotten sophisticated, we do average large wall U value calcs. We don't, our subcontractors do, because we ask them to do it. And tell us if the required project has to comply with NFPA-285. Not how, yes or no. And we can provide, now help us through what will be the acceptable documentation requirements. If you've talked to the code official and he's okay with the engineering judgments, assuming it's by somebody he likes, tell us that. If they won't budge on it at all, tell us that. Those all come into play. But you have to define the cladding. We don't want to get into that. The delegated design engineers have to become responsible for that whole discussion. And from a general contractor, subcontractor, we got to pick people who are qualified accordingly. It's up to the contractor then to determine which one works best for us at a particular time, particular application that our group of friendly subcontractors want to work with at this condition. If they're working off a swing stage, their answers are very different than if they're working off of a 110-foot lift or a hydromobile. It really makes a difference. And the cladding attachment impacts all of this. So sort of in closing, Ask your contractors what they think. Talk to them. If you got to play in the hard bid market, talk to them after they're on board. Otherwise, talk to them ahead of time. Collaborate. We all want and need to do it right the first time. If we end up doing it 2 or 3 times, you're going to be working with different people the next time around because we're going to be out of business. We have to learn how to do it right. Don't believe everything you hear. Challenge the process. Challenge us as contractors, certainly challenge our manufacturers, reps that we do all rely on, but challenge them. Don't believe warranties. And if you're going to put your faith in warranties, read them. They're worthless. They're written to protect one person and one person only. That's the manufacturer. They're not written by their marketing people. They're written by their risk management attorneys at the sole and exclusive right. They'll tell you they'll replace the whole building. They'll cover everything. Or at their sole and exclusive option, will refund the cost of their material. That's not even what we buy it for, it's what the distributor buys it for. They all are written that way. With maybe the exception of some of the single-ply manufacturers who started this whole mess in the first place, in my opinion. Focus on end results. All our AE insurance providers have been telling us for years, don't get into means and methods. You guys are heavily into means and methods as it comes to this exterior wall stuff. Give the contractors some flexibility. And I say we can do that via delegated design, which is impact for us, but that's the pro and the con. Listen to Joe and Jesse. We got 2 great experts out there. Read as much as you can on what they've said. They got great stuff. And openly share what we've learned, where we've had problems, and how we can do it better tomorrow than we did today. John and I will be around up here for a while and certainly out on the floor. Thanks for your questions. Thanks for your attention. And send us an email.